Imagine trying to merge 8 lanes of speeding traffic into a single superhighway, right?
Yeah.
About a single car braking.
Yeah, that sounds like a complete nightmare.
Exactly. Well, in the broadcasting world, that superhighway is uncompressed 4K video. And today we're doing a deep dive into the device that basically plays high-speed traffic controller for the media you watch every single day.
Right. Specifically, we're looking at the AJA 12G-AM-T 12G-SDI 8-channel AES Embedder and Disembedder. I know, it is a seriously intimidating alphabet soup of a name.
It really is.
But its mission is actually incredibly elegant. It manages how these massive video and audio signals are perfectly synced and transported in, professional broadcasting environments.
Right, because when we say 12G SDI, we're talking about the immense bandwidth required to push pristine, uncompressed 4K video down a single cable.
Oh, absolutely.
So managing 8 distinct channels of balanced AES audio around a signal that that has to be an incredibly delicate process.
It is, yeah. And the device handles this through 2 main functions. There's embedding, which injects sound into the video feed, and disembedding, which extracts it.
Okay, simple enough.
Right. But what stands out in the specifications is that the disembedding process is actually always active. It continuously pulls sound from the video feed, instantly giving you 4 AES audio outputs.
Wait, but if it's always extracting audio on autopilot like that, doesn't that sort of limit your flexibility?
How so?
Well, if I'm running a live broadcast and I need to add completely new audio over the feed, I really don't want the system just blindly defaulting to the original sound and locking me out.
Oh, I see what you mean. No, it doesn't lock you in at all. The embedding side is entirely user selectable.
Oh, really?
Yeah, and it works on a channel pair basis. So picture a live sports broadcast. You might want to pass the ambient stadium sound through completely untouched on certain channels.
Right.
But then you can inject the live commentator's audio into entirely different channels on the fly.
Okay, so it's less about preventing an audio pileup and more like opening up designated carpool lanes. You choose exactly which audio feeds get to merge into that main 4K video feed and which ones stay out.
Precisely. You control that merge using the included XLR breakout cable. Since that cable handles 8 channels in and 8 channels out, broadcast engineers have total command over the mix.
Without ever interrupting the core video system.
Exactly. Untouched.
When you step back and look at that entire data package, so uncompressed 4K video, 8 injected channels of audio, plus the HDR pass through the specs mentioned, it's just an immense amount of data.
It is massive.
I imagine pushing that much data over standard copper wire would just result in, massive signal degradation if you try to run it across a sprawling stadium or a massive studio lot.
Yeah, standard copper physically chokes on that volume of data over long distances. Which brings us to the LC Fiber Tx part of the title.
Right, the LC Fiber single-channel transmitter. Why rely on fiber optics here?
Well, by essentially turning all that complex data into pulses of light, broadcasters can maintain perfect signal integrity across huge venues.
Wow. And the processing speeds required to actually make that happen are staggering. The spec sheet lists the 12G video latency at just 3.2 microseconds.
Right, which in a broadcasting context means that processing happens in a tiny fraction of a single video frame. It's basically zero latency insertion.
That is insane.
The ultra-high-definition video enters the device, gets perfectly synced with a customized audio mix, and shoots out via fiber optic light instantly.
So the next time you are sitting on your couch enjoying flawlessly synced, gorgeous 4K HDR media, take a second to appreciate the hidden hardware making it happen.
Yeah, it's wild to realize that a small form factor device like this AJA converter is doing all that heavy lifting.
Running quietly on just 5 to 16 volts of power, too.
And costing around $1,235. It really is the unsung hero keeping that digital superhighway flowing perfectly.
It really forces you to consider the sheer scale of modern engineering. If this hardware can process complex, ultra-high-definition video and 8 independent channels of audio in just 3.2 microseconds.
We're talking about timelines our brains literally cannot even register.
Exactly. It raises a fascinating question for you to ponder.
Yeah.
How far have our technical transmission speeds surpassed the actual limits of human sensory perception? We've built a traffic controller managing a superhighway moving so fast we can't even see the cars go by.
That is a wild thought.
Definitely something to think about the next time you hit play.